also happening and done in the microwave. So we come now to another field, is microwave seed treatment. In Germany and Europe we have the problem that we are not allowed any longer in some parts of Germany, for example, and in Denmark, for example, and in Finland, they do not allow to do chemical coating of seed materials. It is forbidden because they say, the government argues that they bring chemicals into the soil and nobody knows what's done with these chemicals in the soil, and they do not allow chemical treatment of seeds. So we have to look on alternative methods, and one is shown here. In this case, sorry, winter wheat is not a very common fruit here in Thailand, but it does not matter whether you take winter wheat or some other seed material. The effect is the same, but the diseases change, but not the effect. So I think you will understand what I want to explain here. We have here winter wheat seed infected with a very serious disease, Fusarium pulmorum, and this is also a disease which cannot be removed by means of chemicals, because this fungus is living inside the kernel, not on the surface. It is living inside the kernel and you cannot remove it. But we have very sincere Fusarium problems all over the world, and here you see a way how we can remove this. This is the control which is infested by this fungus. You see here the seal around the single kernels. No germination is happening and is possible, and this is material which you cannot bring into the field, otherwise you will get no yield later on. We put this material, the same kernels, and a microwave application system for 3 minutes, and we got this result. Totally destruction of Fusarium pulmorum, and you see the germination is excellent. Every kernel is germinating, and there is no problem with the fertility. And this is a typical way how you can remove seed-borne diseases. You cannot remove the diseases which are in the soil, but you can remove seed-borne diseases by use of this technology. The same we found out in sugar beet seed. Here you see sugar beet seed, single kernels, and they are also infected by another fungus, Fomarete. And here after microwave application, and you see also that they are, the germination is okay, everything, and the fungus is removed by use of microwave application. Due to these experiments, we came in contact with the university here, with the Post-Harvest Technology Institute, and Natasha Kritigamas is working especially on this topic, removing seed-borne diseases with high frequency, not with radio frequency, but with high frequency. And this is done because we think that this is a very interesting technology for this purpose. And you have also problems with seed-borne diseases here in Thailand, and it might be an opportunity to overcome these problems. Here you see another change in the system. Now we change from microwave to radio frequency seed treatment. This is exactly what is done also in the experiments here. We have winter wheat seed infected by Fusarium graminearum. This is also a fungus which is threatening the material, and here we have the control. And you see the germination is bad and the infection rate is high in the control group. And now we change over to radio frequency seed treatment, 300, 400, 500, 600, 900 seconds. And what happens after 300 seconds of application? The infection rate is decreasing and the germination rate is increasing. And after a longer processing time of up to 500 seconds, we have a total remove of the infection, and we have quite sufficient germination. And to explain, this is a hard job, very hard and critical thing to kill one biological system and let the other thing biological system survive. The embryo in the kernel must survive this, and the fungus should be killed. This is a hard job and very sophisticated thing to realize. This. You need many experiments for this purpose, but it is a good opportunity to get rid of chemical treatments. It's not that I'm against chemical treatments, but the market is against it. And therefore we have to find new possibilities. I have no problem with it, but the market demand and the consumer demand goes in another direction. Therefore we have to develop new technologies for this purpose. And here is a typical result of the common experiments we make with Dr. Lucke here in the department of in the Post-Harvest Technology Institute. This is a problem, a severe problem. They told me you have here in Thailand. This is the control of rice weevils in rice, and we made these experiments. We had a control, and these experiments were done here in Chiang Mai. We put 100 alive insects into a certain sample of rice, and then we started radiofrequency treatment. In this case, with a temperature of 50 degrees for 3 minutes. That does not mean that we applied radiofrequency for 3 minutes. We just heated up the product up to 50 degrees centigrade, and then we stopped the whole process and left the material tempering under these atmosphere, under these conditions. And you see, after 3 minutes of time, we only found 7 alive insects and 93 were dead. And in a special case here, temperature of 60 degrees centigrade, 1 minute time, we did not found any alive insects, 100% were killed. This was just a preliminary experiment to find out what's going on and whether this is a possibility, and we can explain easily why there is a technical problem with the device, which yesterday I saw that you made a good job and solved these technical problems, so that future experiments will show what's going on in the system. But we have to look whether we affect also the eggs, the larvae and the puppies and so on in the material, and I'm sure that additional experiments will be carried out here in Chiang Mai. Because in Germany it does not make sense, we have no rice weevils, and we don't want to have rice weevils. So, now I gave you some impressions of the experimental results, but perhaps you are interested how microwave systems in industry look like. You have a household microwave oven, but you have perhaps never seen something in the industrial level. Here you see a typical Neander continuous flow dryer. And the problem in industrial scale systems is, perhaps we can explain it here. You have an open system. At home, you have to close the door and then you can start the operation of the microwave instrument. In industry, this is not possible. You have to realize a continuous flow experiment. So let me say you have to leave the door open. And we do this normally with a tunnel. We provide a tunnel system which can be consisting of several tunnel segments. The more you need, you can get. And then you have a belt which is running through this tunnel. We put the material on it. It runs through the system, and on the other side, everything is done, and you put it away or use it for market or something like that. Here you have the same, but in the vertical direction. This is an elevator going down and coming up through the system. Here you have a special microwave system for vulcanization of rubber. This is an industrial chamber dryer. This is working discontinuously. You put the material in, close the door, dry the material and open it and take it out. And this is the most sophisticated and high advanced drying technology. This is microwave vacuum drying. This is used in biotechnology and so on, where you have to provide very clean conditions. And here you see our microwave test facilities, and my institute in working in this is, here you see our experimental microwave dryer. It is a typical household microwave dryer, and this is the electronic which is providing the system. Here you can perhaps see that there is a rest of household microwave oven, but the rest is typical technology which you need to control the whole system. This is a tunnel dryer. You see reconstructed in the institute. You see here the belt is running into the open system and the application is done, and this is a special meander dryer for drying of technical products, in this case of a membrane. And here are results or examples of application devices for radio frequency. Drying of paper, for example, drying of mattresses, of textiles, everything is done with radio frequency. I think several garments which you wear here inside are dried by radio frequency. This is a typical field of using it in technical devices, and here you see technical devices for drying of glue lamp or other plastic material, but also mattresses of diameters of several meters. You have 10 or 12 mattresses lying over each other, and you can dry them also with radio frequency. So the hardware is on the market, but we have to adjust it to our purposes. And this is now the radio frequency instrument. Actually, our radio frequency instrument in Göttingen, but if you would like to see it, I think it's quite easy. Tell Dr. Vicha, because the whole instrument is now here in Chiang Mai. In Germany we have a problem, we have no products to be dried there, only wheat and sugar beet and nothing else. And therefore we decided to bring the instrument where you have really interesting agricultural products, and perhaps the most interesting area in the world here is Thailand for this purpose, and therefore we brought this instrument here to the department. I'm glad that you provided a wonderful laboratory, better than we had in Göttingen. They constructed a new laboratory with aircon and everything to get excellent research surroundings here, and I'm glad that we did this decision, and our experiments on the killing of rice, we will show that we are, I think, on the right path with this cooperation, and I'm glad that we started this experiment here, especially in Chiang Mai at the Post-Harvest Technology Institute. Advantages of dielectric heating. So, fast heating, especially to very high temperatures. If you need high temperatures, you can do this, and this might be useful in the case of killing of bacteria, for example. Fast heating means the product is only threatened by heat for a very short time. It's quite ultra heat operation or something like that. Immediate operation. You put in the signal and the material is becoming warm. Product safe. You have no problems with the product quality because you do not add anything. And it is not radiation. I want to point out this is not radiation. This is not ionic radiation or something like this which we put on. It's only heat. We have high process velocities. We got, if we make it in an appropriate manner, we got a homogeneous heating. It can be energy saving. We have compact constructions, as I pointed out. We have modular units which we can adopt to every process. And this is an important factor. We need no carrier gas for drying process. We need no air or something like this. This might be, especially in the case of sophisticated products, very important. And we have also an instrument for automatic quality control. I will give you just an example what I mean with this. In our institute, we made some experiments with this machinery here. And we put in some washing powder from different companies, and we measured the electromagnetic impedance. And we found out that with the electromagnetic impedance you can identify the weight, the mass flow of the material, and also its origin, that you know exactly which kind of washing powder it is. And the idea of this, came into existence when I discussed with a company who is providing radio frequency instruments. They reported me from an experiment in the car industry. In the French car industry, they use radio frequency for gluing the windows into the car. And sometimes the company, the radio frequency manufacturer, got information from the car manufacturer that something with the instrument is wrong. Because it always showed failure. They did not know what's going on, and it worked precisely, but from a certain point of production it did not work precisely. And they looked into it and found out that the system is okay. And nobody got an interpretation of the problem, and after a few days they asked the chemical company which produced the glue whether they changed the material composition. And they said, oh, yes, we did so. And the consequence of this was that the impedance changed, and this was measured by the instrument. And therefore I'm quite sure that with radio frequency you can measure the electromagnetic impedance also of fruits and vegetables. And if this changes, then something with the material must be wrong. This is a hypothesis, but I'm sure that this will work. It works in the case of washing powder and other chemicals, and it will also work in agriculture. That means that we have an opportunity, but there is research necessary to prove this, that we have an opportunity to, for example, measure the quality of a mango fruit without cutting it and making chemical analysis and so on. And this is the reason why I say we have quite an automatic quality control. Yes, this was my presentation. Thank you for listening to me, and I promise I will look the first match of the German football group tomorrow here in Thailand, and if they do not win, I prefer to stay here, because I don't want to come back to Germany in this situation. Thank you for listening to me, and I would like to discuss with you. Thank you very much.